started something like 3,000 kilometers 2 days ago, because this was the date was set. I wanted to be here. We have guests not just from Munich. We have guests from various places in the whole world, so to say. And as I spoke there in the hall, we have so many nationalities here. Like I've heard a Spanish group. Who speaks Spanish? Come on. Buenos dias, vale. Who is here? The Portuguese group. Yeah. German group. Serious. Yeah. Huh? Good. Sehr good. Deutsch. Okay. Polish. Any? No. All right, we can do this grouping later. Let's start the meetup with what are we actually doing here today? It's a question I guess everybody has. We have 2 talks and 1 open slot. That will be either a panel or lightning talks. We want to be interactive with the community. We want to make you also try yourself as a speaker, maybe even today. If you have anything interesting to talk about, like, I don't know, typical thing in the conference is starting from your favorite console tool to your best alternative keyboard layout, mechanical keyboard thing, your conference travel, conference activities, anything, share it. You have a group, meetup group in Munich, competition of us, share it. We are better anyway, so it's fine. So just shoot it. Anything you want to share with Munich community, this is the place and this is the day. This will be the last slot of today. It's a sort of an open session. So think what can you be speaking about. It's easy, like 1-2 minutes, open microphone, so to say. You can, if you can sing, you sing. If you can rap, you rap. You can rap Python code with ChatGPT. It's no big deal. But we start with more serious talks. So first, we want to know about the company. What is ClearOps? Who is working at ClearOps here, by the way? Okay, so good, good. I'm sure that guy also works at ClearOps.
Yeah, I don't know him, but maybe.
So I think, yeah, we start with introduction of the company we're in, our hosts. During the break, we will tell you more about our community, what PyMunich is doing. We're also doing not only events, we also have an agency doing software development. So we will talk about that on the second break. And then the third break, again, is open microphone where you are running the show. So first things first, ClearOps and William, was it? Correct. William, yes. With 2 L's or 1 L?
Double L.
Double L. William Double L. Please some warm welcome to the stage. This is your microphone for streaming.
Thank you.
You can just plug it.
Awesome. No, it's okay. It's okay. I'll just keep it in my hand.
So tell us what is ClearOps, what it's doing. What are you doing there as well?
Yes, just from my side, very quick warm welcome to all of you. Thank you for being here. My name is William. I'm the founder and CEO of ClearOps. I'll be not introducing ClearOps today because Nikolai is doing it. So I'll be handing over to him. He's our head of IT. He's the one who is behind our product, everything that we're doing here. He is actually responsible for shipping the stuff that I'm overselling because I'm more on the commercial side of things. So you can imagine that typically this is stuff we don't have, right? And at that point in time, Nikolai comes in and saves the company. So he's the hero for today. He's the master of technology. So that said, Nikolai, very much looking forward to hearing your talk.
Thank you. Too much pressure.
Yeah, well, Nikolai has one.
I have one.
All right, so I think we will applause to Nikolai. Yeah.
Thank you.
I'll take your picture before he starts. Let's take a selfie with Nikolai. Come on, Nikolai. Will you rock the stage?
Yeah.
Then do it. Again, applause. Come on.
I need to.
Please share your screen to stream out.
Yeah, 1 second.
Yeah. Thanks.
Sorry. 1 second.
Yeah, just whatever.
Did you notice
Where is it?
catering? I really like when we get one step out of pizza. It's little things they matter. Do we owe it to Christina? No?
Is it visible now?
It to William.
Yes.
We have the taste.
Nice.
Yes.
Turn the hotkey for presentation for the full screen.
Good.
Today I want to talk to you about how we built our in-house solution for data processing. But before I want to talk a little bit about us, who we are, who ClearOps, what we are doing. And by this presentation, actually, I want to, start some kind of conversations, first of all, between buy and do it yourself, right? Build to buy, but also about how do you solve similar problems. So in the pause, we can potentially raise hot discussions about how to do things properly, which option do you choose, and so on. But yeah, before I want to present about ClearOps a bit. So we are in a startup. We are quite distributed in the world, and this is our main hubs. But technically, like there's more places where people live right now, like Spain.
You have any job here?
Yes, yes.
Market, Costa Rica could go on your list.
Yeah. Yes, and we also have fun together. We like to spend time to celebrate our wins. What we are doing, our mission is simple. We want to keep machinery world moving. Why? Because like in the world, there's 2 billion machines which harvest food, build homes, transport people, and make our lives better and better, right? And of course, what is important to ensure is that all these machines are working 24/7, right? They always need to continue doing what they do. And to what we saw is that like there's the suppliers, there are OEM, there's the dealers, and there's the owners of the machines, and they are disconnected. They do not know, like suppliers produce machines, for example. They sell it through independent network of dealers to end customers, machine owners. But they do not know how dealer operates. They do not have visibility about how their machines supported and maintained. At the same time, dealer do not have any information about like what's happening with the machine, because IoT services, they are connected to suppliers or OEM. And what we decide to do is to connect them all together in our platform and provide visibility for one group and efficiency of operations for another group. For that, we build a platform where we connect both OEMs and dealers and provide some kind of different services for these two groups to make them efficient in their daily operations. And at the end, to reach uptime for machine owner, right? But we see our, in brightest future, we see that we are not just a platform, we are a data company. Because if we connect all the dealers, not all the dealers, but maybe all the dealers, we'll see, and OEMs in our platform, we will have a huge amount of data which can be used to improve and make their operations even more even more productive, right? Help them even more in their business at the end. And yes, in a few years, we see us as a data company, as some kind of marketplace where different companies can provide, use our data platform to provide their services to our customers. But today I want to talk about simple case, right? So one of the things which we do is we help our dealers to, we want to ensure that right part exists at right time in the right place. And to ensure that parts ordering should be efficient, as efficient as possible. Of course, dealers, sometimes they are not able to, they do not have proper planners. They busy with fixing machines, with maintaining and so on. And that's why we act here, and we gather the data from OEMs, suppliers, and the dealers in our platform. Then we process the data we do forecasting based on their orders history, their customer order history. Then we do inventory planning, and at the end, we generate a proposal for the dealer to make sure that dealer will have right parts at the right time. And to achieve that, we already had some kind of pipeline for that, but it was not scalable, it was not efficient, and it started causing some troubles for us. So we decided to do a discovery and find a better solution for us, scalable solution. Oops, sorry. And yeah, we started with the requirements. Of course, requirements were some kind of, it should be some general purpose framework. So we wanted to execute not only this specific operation, but also in general, like we have many more operations in our system with the data. It should be fairly simple, so our integration partners could use it as well, and other people can understand it. It should be performant enough because we have quite a lot of jobs to do, batch jobs, and it should be scalable, cost efficient, everything like that. So after some time, we thought a lot, we talked to each other, and we decided that probably we can try to build something ourselves. And we came to some kind of, develop some kind of architecture, how we can do that. We stopped at several components which we need. Like, first of all, of course, we need to some kind of schedule the jobs. To execute them, we need to execute the jobs and crunch the data. And we need to like load the data, store the data, and so on. But it's all in Java, right? And I think we have here Python conference. So let's help Dora to find Python here. Python is here, actually. So if you look into one of the component, executor itself, so executor is responsible for running the jobs, right? Specific batch jobs. And we decided that executor will just control the jobs, but all the work will be done by this Python part. So then I see data, and see here word crunching. I always choose pandas and NumPy probably. Then we always take requests if you need some kind of I/O operations, HTTP operations. We also took some reactive framework to make these operations more efficient. But we have like, as we saw here, like we have Java executor which controls all these operations, right? But also, and which needs to communicate with the Python. But also we had a lot of code written in R, like all our algorithms around forecasting and inventory planning, they were written in R. So Python was in the middle layer between Java and R. So this is our first attempt to write this some kind of Python framework, Python DSL. So we just wrote the code around to give possibility for developers or anybody to write any kind of sequence of functions to perform the job and to provide some additional context about the job, like on which data it should operate. Yeah, and here's just an example of the function which we write. Like we have some kind of code over it to run the functions. We have requirements, which exactly data we need. We run. We can define which data this job produces, and then we have a method which we need to override and which receive this data object. And the whole magic of our Python framework is in this data object because it hides all the complexity of loading the saving the data. You just technically, for example, if you need some kind of data from the system, you can just call like data SKUs. SKU is a stockable unit. It's just a combination of part and a specific location. And all the I/O operations, the framework by itself will load all the data into the memory, and then you can work with the data without knowing all these details, what's happening outside. And it's also change behavior depends on the context and past parameters. So you can limit the scope and say, for example, I do not want to work with the whole data, but only with a subset of data and so on. And yeah, it also integrates well with the data frame. So if you want to save, for example, pandas data frame into our storage, you can just assign to data frame, and it will be saved automatically. You don't need to convert anything or call any operations. What we saw after the first iteration is that like I/O operations took almost 70% of the execution time, which wasn't great. It was too slow, and we start thinking how we can improve it. Of course, like we need to reduce this I/O operations, right? And we came to simple solutions. We added additional operator in our DSL, which technically just check the functions, check their requirements here, for example, concatenate them all, combine them all, and then just do all the I/O operations in one batch. So it reloads all the data, it converts it to pandas data frame, and then we can operate this data like already in memory. And it was quite great because we achieved results which we wanted to achieve. So it was a general purpose. So you can ignore this data object and can do anything you want. You can send emails. Technically, you can write any Python code you want in these functions. It was fairly simple. We just missed some kind of, how to say, UX around it, a bit better, nicer UX. It was performant enough, and it's still performant enough. With it, we run approximately 500,000 to 700,000 jobs per month. And it's not the big number, of course, but if you look into this graph, it's how we run the jobs. We can see that usually we have very low, tiny window during the day when we can run these jobs. So, for example, for one of the clients, we have only two hours window where we receive all the data, and we need to crunch all the data and save them and provide results for the client. But yes, per month, only in one region, we process around 11 billion SKUs in a single region. Yeah, and we use it for its standard executor configurations, which is approximately 1 vCPU in AWS and 4 gigabytes of memory. But we have also support some kind of profiles, so we can increase resources if we need. It's scalable horizontally, so we can with every new OEM or dealer, we can increase amount of executors and run more and more jobs. Depends on our needs. At the same time, it's cost efficient. Machines are small, and most of the time they even not started because we have we run them we scale them according to the load and to the system, and easy to run. So it's probably arguable, right? Yeah, Java developers doesn't like it. So, and by using this all this data by using our processing framework and by automating this order process, we achieved quite good results for some of our customers. Actually, for all of our customers, but this results for some of them. So we increased some metrics for them. This metrics is around spare parts, right? So in their warehouses, because to keep machines up and running, they need to have enough parts in their warehouse, and they need to have right parts, not just some random parts, right? And in the past, they had some, for example, parts which are not used at all, like they just literally took the empty space in the warehouse. At the same time, they didn't have enough parts to to support customer fill rate. And yeah, of course, after that we increased reduced machine downtime, increased machine uptime. So we, quite happy with what we achieved with it, and we have some plans for the future. And first of our short-term plan, which is actually going right now, we have a collaboration with the Technical University of Munich, where Professor Stefan Miner with two doctors help us to improve our inventory planning and forecasting algorithm and integrated it into our platform to achieve even higher results. For example, like increase customer fill rate even further. Yeah, and we have some goals which we want to achieve with it, and I think we will run the first version already in May, and potentially later we can share with you some results about it. And of course, on the long run, we need to think like, do we want to stick with our internal in-house solution, or do we want to go with some available solution? Is it open source, or is it something which can be both? Like that's in front of us as well. That's probably it from my side. Thank you for listening. I hope.
Questions.
Yeah.
Okay. 1 sec. Whom do you like more of them two? Catch it.
So thanks for the talk. I wanted to ask how many APIs or like basically data sources do you have integrated, and is it all like REST? Because you just said it's like requests, but I also mentioned it's like OEMs or dealerships having like very special ways to retrieve the data.
Yes, they have very, very special ways. Sometimes it's crazy, but it's like, how to say, outside the scope, because we have another product which calls connectivity, which we call connectivity, and this product is fully responsible to deliver the data from outside to our system and from our system to outside. So this processing, it works only with the data which is already inside.
Okay.
But yeah, like we have, I don't know, thousands probably, some different integrations.
And then maybe a second question. So you're using Python right now in like I would say one part of the company, right? But you said there's like Java, there's R. Are you planning to expand in both directions? Because I feel like Python is also can probably do everything that R could do, and there's great workflow management tools like Airflow or Prefect for like the other part that you have right now in Java.
Yeah, we plan to replace R with this forecasting and inventory planning with a Python code at the end. So yes, we plan to continue using Python, probably expand it, and we like monitor tools like Apache Spark and Airflow, and consider to integrate them. Like we have different options. Like one of the options is to integrate into our platform and make it work together, or like use it to replace our platform, right?
Good, thanks.
Okay. What was the next one? You have to throw it.
I won't. Do I have to throw it? Okay. Is this insured?
Come on. Yes.
Thanks for the one talk. So obviously, on your platform, you have convinced the OEM and dealers to share their data. Otherwise, I don't see how you compute without knowing their inventory and all. So it's more like a business question. How do you convince those OEMs and dealers to share their data on platform?
We have this beautiful guy here.
Yeah.
Who is very
so
convincing.
I think it's so obviously sharing this data is it's a very confidential data, isn't it? So how does that happen?
Well, sharing data always comes with a benefit case that you have to draw, right? What we do here is we keep machines up and running, but of course, keeping machines up and running means that dealers and their OEMs can sell more parts and more services. By that mean, right? So in the end, we're going to the dealers and tell them, if you give us your data, we're not only going to predict what parts you need, but also what services you can deploy and how you can generate more revenue, right? And of course, they don't care about confidentiality the second they smell more money, right? So ultimately, this is the business case.
That's true.
Where
Yeah.
we say, dealers, you're going to sell more parts and more services, and ultimately, the local success of the dealer is the global success of an OEM, right? And this is the convincing bit that we give them.
Okay, fantastic. And the second question is, like, do you also include the geopolitical factors, like some countries putting tariff on other countries, and that also disrupt the chain? So do you also consider those factors?
We will consider them in the future. What's interesting right now is the statistics behind, because networks are disconnected, and the second networks are disconnected, they work much worse. So for the time being, we have a statistical problem to solve. How many machines, how many dealers, and how do we deploy the millions of parts and services required? But once we solve for the statistical problem on a global scale, then we will factor in geographical things, but also weather things, like predictive maintenance and stuff like that requires weather factors. It requires certain rural factors. Is it dark? Is it bright? You know, whatever comes in will be factored in, and we're setting up the foundation with it.
Thank you very much.
Good. If you have one more question, yes, you have to throw it, remember. Good.
Thanks for your talk. You mentioned in the beginning that there's always this question to buy or build. And in your case, I wonder how you're going to decide compared to other solutions that provide, the other person already mentioned, like Apache Spark or Prefect.
Oh, it's always a tough question, right? Because I think there's multiple, things which you need to consider, like costs, operational costs, development costs, support costs, and but also the knowledge base. For example, why we went this way is, back then, when we made this decision, we researched some of the tools, and we didn't see that they fit to our needs. Now I think we have more resources to make proper research, like better research and so on. So, yeah. It's a tough question, but I think we'll crack it.
Are there some?
He tells me a price tag, and I say no, and then we're building it ourselves.
Are there some requirements that you would say are pushing you more to the build side, because it's like so specific to your use case that you can hardly find anything that will
Yes,
fit?
some kind of. One of this requirement was the 8 one, so we already had something in place, and we needed to build something very, very similar to we already had without changing the infrastructure and so on, so just on top of it. And I think that was one of the main reasons why we built it ourselves, due to some time constraints and so on. But yeah, right now we are ready to review it and maybe rebuild it completely.
Good.
I will report back.
Yes, let's do it. The final one. Yes!
Yeah.
Good job. Big applause, please. Well done. Thank you. Thank you. Before we go to the break, a few more organizational things. First, is Marco here? Marco, good. Yes, right. We need to connect the stuff before the next talk, so just be here on time. Good. Then second thing, there are some important people you need to remember in this room. They are setting the rules, okay? When you see the sign, Leon, show the sign.
Sure.
Yeah. This means it's a pause. You all know German, yeah? It's a break. Then there is a sign, no pause anymore, okay? That means you go back. So you show the sign, yes, and then you need to be back because we have timing here, right? So the important person number 1 is Leon. Remember his name. I'll take a selfie. Wait, please. Ta-da! Good. Now the second important person is over there. It's Eugene. Come here. Come here. Eugene is very strong. If you do not commit to following the rules of Leon, then he takes over because he works out. You know? He's like the big boy. Eugene is making live streaming, and most of the technical things on Meetup are on him. So if I'm talking a lot, it does not mean that I run like the majority of the thing. It is still like the equal collaboration. So please, during the break, when you have your beer, come by to Eugene and say, hey, yo, good meetup, man. Cheers to him. So what's his name? Eugene. Good job. Okay, that's important person number one. Then, another important task for the meetup. ClearOps are hosting us. They're giving us nice, fancy food and beer. Talk to them as well. Say, well done, hosting. Host more. Okay, something like this. So now we're going to the break. It will be like 15 minutes, I think. After that, we have one more talk, and then the open microphone. You still should talk to me about the open microphone thing if you are willing to participate. Otherwise, Alex will be singing Portuguese songs for us if nobody else is volunteering. Good. So now show the sign. Show the sign. Pause. Okay. Well done. Let's have some break. Thank you. audio. Does okay. Yes. So you liked the break, you like the snacks, you like the beer. What's better, pizza or is it panini or how can we call it? We have Italian here. No Italian? Okay, it's okay.
Okay.
I mean, it would be good to have an expert to explain these things. Good. We are connecting the speaker number 2. Meanwhile, I still did not get any submissions to our open microphone. So if there will be none, then we either sing a song together. Can German community suggest some really hardcore song? You can sing Rammstein or something. Should be a bit of a punishment as well for low initiative. Okay, meanwhile, I will tell you a few things about our community, about our company. So PyMunich, somebody asked me on the break now, how long do we do it? We started, the first meetup was 2016. So it's a while. It's a while. It's not like it's super regular, of course, but we try to do it every 2 months. Every month in the hot season, so to say. It really depends on you, on the crowd, because if we have speakers is the hardest. Hosts also difficult, but speakers is the hardest. So if we have speakers, we do the meetup. If you have an idea about the talk, you might be not yet confident about it. You will be confident. Talk to us, we will make you confident about it. Yeah, that can also stop you from organizing sometimes. So yeah, if you have ideas about talks, talk to us. If you have a space to host us, your friends, your company, your uncle, grandmother, don't care. We can make it at your grandmother's place. We really not putting any limits on location. We can fill up 100 people in the room. That's usually the limit. Everything below works. So talk to us. Then we also do the work with Python ourselves, with our hands. So we have a small agency. We are Tech5. We are happy to do collaborations. Oh, again, echo. Nice.
Really?
Mute me.
I thought I muted it.
Mute me. Okay, muted me. Good. So we are happy to do collaborations, especially now with AI taking over everything. Also, our shitty code is now really easy replaced with AI. So we are looking forward into that direction more and more. We are trying to jump on this train, and for this we are very interested in people who can join our team working as an AI engineer. Obviously, Python should be your preferred language. I think it's obvious at this meetup. So if you're curious about this, also like a side job, talk to us. We'll find some flexible conditions to you to try it out. It's really fun. We are so much involved in community, and this is sort of a good thing that works together. We're doing these events. We're also coding ourselves, and it just works really nicely. Are we ready? Good. Rock about AI, because it's a very trendy topic, right?
Yeah, well, yes.
Very good, very good. So please, we need a warm welcome for Marko on the stage.
Well, the best way to get the attention is to not do anything, kind of work. So I want to start. So the presentation is about physics with AI. Actually, when I did it, in the end, it turned out actually it's better for chemistry. And you will see why. So you can use physics, or for chemistry, it actually works better, because if physics describes things better, chemistry is a lot of rule of thumb. Hope there are no chemists in the room, because, yeah. So why would we use physics with AI? Why not just physics? Why not just neural networks, right? And the motivation is a bit like you have a optimization landscape, has a certain shape, don't necessarily know how it is, and it's very difficult to find the global minimum, right? And if you use physics-informed neural nets or other constraints you use, you actually restrict the ways it goes, and it should rather go to the global minimum. So like kind of shaping the landscape in a way you find it more easily. And I also use an example because what you have quite often is if you're in a chemical lab or even in a physics lab, you don't necessarily have a lot of data, right? So you might have that landscape. If you have all the data, you can represent the landscape, but quite often you don't even know how the landscape looks like, right? So if you use AI, you can actually, if you use physics or chemistry information, you can actually shape it a bit better and kind of prevent it converging somewhere there, right? And the example I give is like adhesives. So I kind of mentioned it before, but what you have quite often is that companies have a need, they need to optimize. There's a lot of pressure you have right now, especially in Germany, but all around the world, right? Energy gets more expensive. Germany has a very, very strong chemical industry, a bit smaller than the car industry, but I think it's car industry is maybe 5% of GDP, chemical industry 3% or so. So it's not insignificant, and there's more know-how into it. Maybe it's more difficult to copy, actually, I would say. The problem is they're not prepared for AI. They need it, and one of the biggest problems is you cannot publish failures, right? So big companies, very big companies, they might have the data, but they also don't have it in a proper way. Smaller companies don't necessarily have the data publicly available. You don't have the things that didn't work. You cannot publish that. No one is interested in that. Also, it's not necessarily labeled. You have some data, maybe an engineer or mechanics writes down something. Some of the parts are not scanned because you see it, obviously. You don't need the data, and it's just in there. So you have to deal with a lot of incomplete data, unlabeled data, and contradictory data. Sometimes the data shows in one way, but the next iteration step was in the other way. What do you make out of it? If you don't really understand what's behind it, it's very difficult to come to a good conclusion, right? And also the interpolation between scarce data. I will show an example later on the next slide, where actually it is a non-linear process, but you only have a small data points and you don't really know what to do in between the data points, right? So if you know a bit more how it should behave, more like this shape, more like that shape, maybe it is straight, maybe it's monotonically increasing, decreasing, things like that you can know, and you should also include in a way. Quite often you have an inverse problem, right? A typical example, Navier-Stokes equations, or you measure a signal. There's a mine there, for example, in a military context, there's a mine there, you just get a signal, like an acoustic signal, for example, where it actually was. So you need to reconstruct it. Or if you use femtosecond laser pulses, you have the same problem. You get a signal, but you need to kind of reconstruct it. And also, what is very important, you get an output. The client realizes that, and there's always a cost to it. There's an effort to it, and actually they want to reduce the effort. So if you can predict and result, and okay, that is trash, that's also an added value because the client doesn't need to do that. They want to save labor costs, they want to save material, save money, right? So then that's quite important to interpret your data. You have all that explainable AI, but if you can include the physics or the chemistry or some knowledge from the mechanics, you can already tell that because the mechanic will know, okay, that is not true. Why should I use a program? But if you can include that, it also increases the acceptance of the client for that. And here are just some applications, right? I called it pins, but actually it's a bit broader. Our marketing team calls it like deep integration or deep knowledge integration, and pins is a part of it. So you can imagine different ways how to do it. For example, here, like shows a BMW from the website. I don't really know how to quote that. But I took, and what you can see here is you see a lot of different shapes, right? Shades. And that is actually quite important to show you the shape of the car. So actually the coating of a car is really important. And this is one of the quality signs of the Germans and also the Chinese who copy that. Americans don't really do it, but you have here high quality, the coating. That's exactly how the designer wanted it. So you need to be precise on that. And that is really not easy. To the best of my knowledge, even the physics theory doesn't even include those effects, right? There are small mirrors in it that make it more shiny. And then you even have sometimes cars that change the color. So it looks really nice. If you have you have that car, you want to have your boat or your helicopter have the same color, you can also do that. It's just you just need a lot of money for that. It is possible to do, but it's not easy to find the same color. So, and everything that is coatings, it's the same problem. You see a result, but you don't know the recipe to it. How do you find the recipe? So it's an inverse problem, because you can have, in theory, an infinite amount of recipes to get the same color, which is kind of infeasible, right? Here I think that is from Navier-Stokes. That's from a paper where you can see how they kind of simulate it. So what you can also do, if you do a simulation, you run it, but you don't really have the resolution, right? You can inform your neural net, and you can interpolate between the points. It's also quite useful. What we notice is the extrapolation is a bit more difficult in our cases. And then, of course, like I mentioned, this is maybe chemistry, but this is clearly chemistry. So if you have a polymerization, you have a lot of different processes. And the thing is, it's more like a rule of thumb, because you say, okay, because of that concentration, this increases, but actually the whole system changes. There's like a non-linearity to it. So it doesn't just depend on the concentration is decreasing, but also the viscosity. So the whole environment changes. And how do you cover that, right? You can add perturbation theory, add some terms to it. You need to fit that. You need more data. You can also do a simple design of experiment, right? But you need a lot of experiments to do that. And the model is not necessarily sufficient. So you cannot necessarily take one and apply it to the other. But there are lots of inverse problems. And I think the most known, or at least I know that pins are mostly in publications, especially for the Navier-Stokes equations when you want to simulate that. And then I want to give you an example how this would actually look, or special physics-informed neural net. So you have your loss function, can be mean squared error, can be anything else, right? That's always larger equals 0. And then the idea is basically form a Lagrangian, right? So you add something to it that should be 0. So if this is violated, it is positive, it is bigger. So with that coefficient, you can kind of choose, yeah, okay, you can rely on the physics or the chemistry, or you can maybe rely a bit less. So this is a hyperparameter you need to basically fit. And to make that a bit clearer, I chose here an example. I don't know how you're familiar with that. It's maybe a bit far away from IT. But actually in adhesives, you have kind of a chain polymerization, right? You know that at home, you want to glue something to it. It needs to fit on the specific surface. Sometimes it's 2 components, and then you have quite often polymerization, or you use UV lights to initiate that, right? There are different forms of it. I mean, in your mobile phone, most of it has a layer of adhesives to actually make it also thinner, right? And to have some other properties. Basically, you have different steps. Initiation, so you start to make it active, then one reacts with the other one, the activation is still there, it continues, you have a chain, and at some point, if it hits another active one, it annihilates and the reaction is finished. So there are different parameters how you can actually increase the chain size, and that all has different properties of your final result. Yeah. I choose one equation. This is basically, I'm a bit of a chemist by education, but I prefer physics. So I went more into the physics part. That's what I'm saying now might not be completely right. But when I look into more experimental chemistry, I don't find much more than that. Please correct me if there is more to that. But basically, it is an equation that is just put into a linear form. So in the lab, you can easily extrapolate it. Here you have the slope. There you have the offset, and then you can actually determine that, right? And what you have in that equation is actually the degree of polymerization. So how long is actually the chain, and then what it depends on. Like you have one that doesn't have a chain transfer agent, so it goes from deactivates the chain, goes to another chain. You have basically 2 concentrations, but yeah, we leave it there. I explain you later why this is a limitation and why you actually need some non-linearity terms or some correction terms to it. So actually, how can you put that equation into a neural net, right? So the idea here is simple. We can just write it 0. 0 equals this minus that. I forgot the breaks. Or did no, I didn't. I didn't. I should have written it the other way around. But this actually should be 0 if that equation holds, if your data holds that equation. And this is basically our physics loss function, and then you add a coefficient to it. Of course, you need to square it or take the absolute value to be always positive. And you can always add a 0 to it, right? So here it's written in another form, and basically you have your normal loss. You add a 0 to it. It should be 0 if it holds. So it should be okay, right? And then we can actually write it like that. You can do it a bit differently. You can say, okay, it should be 0, but you know it's not 0. It's always 2 or something. Then you just make a then you just make it, if it's bigger than 2, then it shouldn't be added to it, right? Is that kind of how I imagine it? You basically you create a valley, and then you can with that parameter you can decide how steep it goes. So if the algorithm goes that way, it will be punished because it needs more energy to go up. And the same way, if you say 2 is still okay, plus minus 2, so the valley is kind of broad. And then here, well, I add the squared to it on that step just to show you from that logic. So now going back to it. So you can basically add to it. There are different ways to do it, right? So you have your loss plus then some physics to it. So then you need to find the best way how it really predicts your data, right? Cross-validation or so, that you can have an improvement there. But you can also use it for your training, right? You can pre-train a neural net by creating data that just fake data that fulfills that equation. And then you can keep on training the neural net with it. That's also another way to do it. And here it assumes a linear relationship, right? It's kind of, where does this equation come from? It is basically some observation you find in the lab, right? And the thing is that the radicals, or the active part, is assumed to be stable, right? Because it is always there, except if it annihilates itself. So it's probably in that constant C. But the thing is, it can also change. So this is not taken into consideration here. And also, there's a single transfer. So the transfer can also happen several times, like, right? So in literature, I think they can add some terms to it when you have a second or a third transfer, but it's not taken into consideration here. And where do you stop? Is there a second? Is there a third transfer? How likely is this to happen? This is just a probability of squared, so 0. whatever squared. That is the thing you basically don't know. So you need to kind of fit it yourself onto the data, or just use a neural net and that fits it for you and gives it out to you. So you also have kind of an understanding what is actually the complexity you're missing, right? And it also assumes, so quite often it's just ideal, right? So it works in a certain regime with that and this and that, with certain limitations, but that is not necessarily, you don't necessarily measure it. If you're in the lab, you do your PhD, you work 6 days a week for 5 years, you're always there, you watch it. But once it goes into industry, the company needs to pay for those hours, right? In one way or the other. And what I also mentioned is that basically you have a glue that hardens, right? So it gets more and more stiff. But actually the likelihood that the reaction happens is also the availability of the monomers and how they can move in that solution. And the solution is actually the monomers. So you see, there are lots of processes that are not taken into consideration in that simple equation. And this is basically a big motivation. So you could even say, okay, maybe this equation doesn't even hold. And then you find cases where it holds, but it holds to a certain extent. And then you need to have a high-paid chemistry PhD to do that, or you just need lots of working hours to figure that out. Whereas with your previous data, you could actually use that, make some sense out of it. And this is basically how I should have changed the title in the end. Because maybe you saw that on LinkedIn, it appeared quite often how actually a certain vibration evens out, right? And for that, you don't need a pin because the physics are quite clear. So the physics are often quite clear. The computational time is often too expensive where it makes sense. But in chemistry, it is quite an issue. If you talk to a lab PhD in chemistry, like probably the only expert in that field, right? You use that expert, does some reactions. Okay, this happened, that happened. Okay, I need to go to the different one. Makes sense, right? 5-6 years of training, hard studies before. That works, but you cannot. Quite often, you can not use that expert on a different problem because all is based on experience. So that is actually a perfect case for AI because the intuition we get from all the experiments, all the data we saw, this could also be represented by AI. And what does the chemistry PhD have? The equations and the experience and the data, right? And I think there's a huge potential to use that if you have the negative data, right? And which you normally don't have. That's why it is necessary to include all of that and sensibilize the clients to also track the negative data. Yeah. And well, just some fields with ChatGPT created. You have it in all the fields. I don't know if you know about pharmaceuticals. You have all those medical trials, right? Very expensive. You can argue, yeah, they made it very expensive, so no small companies can join the market except if being bought. But you cannot say from the lab to the mouse or the monkey, whatever, used to the human trial, right? Is there maybe a way to connect that? Those are some certain applications or the materials, right? All the coatings we see around here, there's a lot of R&D that goes into it. And especially to keep that, in Germany, there's a lot of coatings, right? And in Europe in general, to keep it here, to make it more affordable, we need to innovate. And that is one way to do it. And yeah, so this is the team. And I need to add that slide so I can use it as working hours because we are also hiring. So if you want to just reach out on our website, here's our CEO, his email. He said, just send it to him if you're interested, or yeah, whatever. But we can clearly have talks about how you would do it, where you see the problems, how it could help your company in a way that, I don't know, it makes your processes more efficient, but also how you can get more clients because the market is really huge. And with that, yeah, I end my talk. Thanks for your attention.
Very well. Questions? I want to drop this. Yeah. You know.
Hey, thanks for the talk. So I wanted to ask about performance of this loss function. So because I can imagine if you want to build your whole body of knowledge into this training loss function, you will have a very bad time with performance, or it could be very much slower. So do you have any rule of thumb, how fast this should be compared to mean squared error, that it doesn't influence performance?
Well, so one thing for sure is you need to make sure the loss function is built the same way, right? So when there's an update, the loss function doesn't go into another direction or has a stronger effect than you actually lost. This is one of the issues I faced at the beginning. This is something to pay attention to, that when you have a change, that it's linear to the loss function. So how the loss function changes, it's more or less the same way and not does it more complicated. That's one thing. About the performance, so far we haven't had very, very complicated loss functions. Actually, an equation like that already helps quite a lot. So in terms of performance, yeah, sometimes we're fitting it prior to actually that to evaluate it or to pre-feed the neural net, and this is sometimes not necessarily feasible for the client. It takes way too long. So yeah, there we need to optimize that a bit, but you can make it significantly slower.
And maybe second question, could you also, the function you have, added basically as an input and only train with the normal loss function to basically provide it this kind of knowledge you have as just an input?
Yeah, I did that, but then depending how long you train it, it deviates too much, right? So if you put it as an input and then you train for, I don't know, 500, 1000 epochs, depending on your data set, this initial information is a bit lost. Or you mean you pre-train it and then you use it and continue training it? Maybe
I mean, just like basically the function. Like I don't really know what the loss function actually calculates because I'm not like a chemist, but
Yeah.
I always assume it's just like the inputs you have, and then basically scoring it, just saying, okay, this makes sense as like an input or doesn't make sense as an input. So if you just add it, like let's say you have like 10 array of 10 size input, and then this is like value 11 that you kind of pre-calculate on every step, maybe something like this.
If I understand you right, yeah, we need to pre-process the data. That would be one way to do it. So far, we do it a bit differently. But yeah, there could be a way to do it. It's just, I think it would take too long the way we do it right now, but this could be an interesting point to integrate, yeah.
Thanks.
One question. Yes, throw it.
Wait. I just wanted to say that I'm quite bad at caching things, and just want to no problem to hand the thing over. Sir, thank you very much. That was a really interesting talk. I'm just wondering. I mean, your physics constraint. It reminds me about how usually regularization term is added, like Mortmanov L1 regularization or Tikhonov L2 regularization. Yeah, it looks like. And or like in support vector machines, yeah, the constraint are introduced. So the regularization is introduced. So the question is that, if I think from the regularization point of view, okay, I mean, the more data we have, the less we need regularization.
Yes.
So if you had, I guess the main reason for using this is that for your tasks, you don't really have a lot of training data because the source is unavailable, yeah?
Yes, yes.
I mean,
yes.
you have only the
Yes.
outcome, but can we say that if you had, let's say, much more training data, we wouldn't need this constraint?
Probably yes. It's like the thing about large language models, right?
Mhm.
It's probably that, but the goal is for the companies, they don't give out the data, right? They have it internally. And those very, very big companies, they might already do it like that, I don't know. But those, if they have revenue of 400 million, 1 billion, they're necessarily too small to have enough data. And to generate that data, that's actually the cost. And that's what we want to reduce.
Awesome. So the second question probably, so did you test, so which architecture worked the best in your, does work the best in your case? Because there are other ways to introduce constraints, for example, through graph neural networks or whatever. Did you ever compare it? And yeah, comment this.
Yes. So for our cases, so far, I'm not sure I can get too much into the details. Maybe we can talk about it after the talk, but normally we basically, it depends on the data you're having, right? If you have remission curves, like for all the coatings, it makes sense to use CNNs.
Mm-hmm.
Basically, normal feed-forward network quite well.
Okay, thank you very much.
Last chance for a question.
Oh, not thrown. Okay, so I wondered about, maybe it's partially discussed, but how much is it more a, you have some kind of a function that you, where you use the training data to approximate something, or how much do you do classical neural networks that you train with that? So on what abstraction area? Because if you take this loss function here and say this is this physical equation, then you're maybe not wanting to train classical neurons or so like. So what are you using there, or what level are you on? So
it depends on the client. It depends on the data, because a lot of data is contradictory. Says it goes that way, but actually so it really depends on the use case. Personally, I prefer to use neural nets only when I have to, right? So even in that equation I showed before, here I would actually try to cope for that without neural nets, because there can be another term to add to it, and then maybe just fit the coefficients, how they mix with each other, you know. There could be a way to it. And normally this is faster. It's also about performance, to just mix it in when you see it's not really fitting the data. Yeah,
What is transfer?
That's the, what was it? A transfer agent, the transfer, I think, from one chain deactivation to the other. It just shows that example. It's not a real example we're using. Yeah, be careful here.
More questions? we can count this as my question. So my little contribution to Q&A. Good, then. Yes, yes. Then I think we owe a big applause. Yeah, let's do it. Big applause. So if we do not have volunteers for open session, for singing, dancing, show your talent in AT, maybe not, maybe better not. Then I guess we will be closing with this one. We always need speakers, reminding you. So please come by. Yes, say a few words. Maybe just leave a contact, or we exchange LinkedIn, and then you have this brilliant idea in a month, 2, 3, and then you just drop me a line, and we will be happy to have you. It can be as small as 5 minutes, it can be as large as 25, half an hour. We're flexible. It's a community thing. Then, luckily, ClearOps do not kick us out yet. So we can have another beer and hang out for 15, 20 minutes more, if you like. Maybe talk to each other, talk to speakers, get to know each other better. That would be really, really good. Then, yeah, I think that we can close YouTube stream with that. And when we say YouTube stream, we always need to make applause for Eugen, because he's the boss of YouTube. Okay, any closing words from ClearOps, or maybe from Alex? Alex, you want to say something? He voted for Trump. He has a lot of Bitcoins. He's like crazy rich, so it was in his interest. Or you just didn't vote at all. It still counts as vote for Trump. Now you sold. You have Trump coins, I know. Nitish, when is the next meetup? We have an organizer of PyData here. When is the next one?
We are planning. I mean, I'm looking for hosts.
Put some pressure on him. Meet up, PyData, come on. Okay, we will be watching that. Cool. Then thank you for everyone for joining. It's always a pleasure to see this wonderful community. It's your start time now. Go. A break, and thank you, everybody.
Yes.